Okay, so the first thing I wanted to show you, I highly recommend this book, Drawing from the Model, by Frank Melendez. This book has a chapter on computational design, or a whole part on computational design. And what's great about this is it kind of gives an introduction for those who've never worked with Grasshopper or any computational design, parametric design. And it gives you an overview of the capabilities of this type of generative design and how to design with parameters rather than manually modeling something. So it gives some examples. It even does kind of a Grasshopper 101 for those who prefer to learn by, a textbook. This is a really good kind of explanation of the interface. Just to kind of show this. It shows how everything is broken up into a series of tabs and panels. It kind of talks about how the canvas works. This gray space here is called the canvas. Talks about different visualization methods. So if you want to have a translucent grasshopper geometry when you're modeling. And then it talks about components. So we covered this last class where there's the inputs in the component, there's the description of the component, and then the output, right? So when you mouse over each of these, it'll give you different information. So when you mouse over this image of the line, it'll tell you that it's a line and it's drawn from 2 points. The colors mean different things in Grasshopper. So this gray means that there is data being gathered. When it's orange, it means there is no data being gathered. When it's dark gray, that means that it's off or it's disabled. When it's dark green, that means it's selected. And when it's red, that means there's warnings and it's getting information that it either doesn't want or it's not getting information that it needs. So it'll tell you that it's red. So the color of the block is going to tell you something there. Connecting components is as simple as left click and drag. So you click and drag to connect these, and control click to add multiple streams into one. Control click. So if we have a line and a point, say we have a series of points, shift connect, or shift drag will connect multiple wires into one input, and then control drag to disconnect that. Okay, so the very simple command that I've created here is to create a line from 2 points. Okay, so to do that, in my Grasshopper space, I can type point. In my Rhino space, type point, drop a point, hit spacebar to repeat that last command, or I could type point again and click again, and now I have 2 points. And so in order to get those into Grasshopper, I take the point, right click it, say set 1 point, select the point. Same thing here, select it, right click, set 1 point. And now you'll notice that Grasshopper is drawing a line between the two. Now the difference between drawing that line in Grasshopper versus drawing that line in Rhino is that now, when I close Rhino or close Grasshopper, if I were to simply draw a line in Rhino and I move one of these points, that line is not parametric. It didn't just move with that point. However, if I go into Grasshopper and I assign that point and I move this, it's now parametric, meaning I can change this parameter and the model will update. And so that's really the kind of revolutionary workflow that Grasshopper introduces in Rhino, where you can be modeling something, or you can be coding something. You're adding components to your script, and as you're doing that, it's going to update the 3D model in real time, and you'll be able to see that relationship. Okay, so you'll be able to build a script and essentially build your model with coding. Okay, so this can be a workflow that you go in and out from. Maybe you say, okay, I'm going to test some things in Grasshopper, but then once I've reached a point where I'm happy, then I'm just going to go back into kind of manually modeling it in Rhino. Or you can take the approach, if you're more advanced and you're going to design the entire geometry to be fully parametric. So the height of the building can be a parameter, the number of stories can be a parameter, the width. All of these are parameters that you can add in Grasshopper, basically making your own custom command in Grasshopper that you can then design into your own workflow. Okay, so it's a way of kind of hacking Rhino, and kind of Grasshopper lets you in kind of to the backdoor coding side of Rhino that already existed. It was a coding language called Visual Basic. Grasshopper just accesses that Visual Basic without having to code. It's just blocks that you're connecting. Okay, so I highly recommend going through this. This gives you a really good introduction to Grasshopper and the workflow. This is actually what we just did. And, it kind of talks about how Grasshopper looks at data and how information is stored. And it's helpful to know the basics of how Rhino sees geometry. In Rhino, I think the workflow that works best for most people, and the one that it's kind of designed to work around, is you start with a series of points or a series of curves in Rhino, and then you generate surfaces from those curves, and then from those surfaces you generate 3D geometry. Okay, so that's one of the workflows that Rhino is kind of geared towards. It's what it's based on. So in today's tutorial, I'm going to show you something similar. I'm going to show you how to create a series of curves that we generate a surface out of in Grasshopper. Okay, and I'll show you the process, and I'll show you how each step of the way is everything is adjustable, everything is parametric. So you can change, all of these parameters and generate new geometries. And that's the beauty of Grasshopper, is often we're coming up with geometry and ideas that we couldn't have designed if we had just modeled it from scratch, or if we had built a physical model, right? So Grasshopper helps test ideas and helps explore new territories. All right, so try to follow along. Again, this is the canvas. I can hold down my right mouse button and pan. I can use my scroll button to zoom, similar to Rhino. And the interface is broken up into these tabs up here, and each one has a drop down. So I highly recommend exploring this. Again, if you haven't already, go to View and make sure Obscure Components are turned on, right? This should be blue, because this is going to show everything and not just kind of hide things. And similar to Rhino, it's broken down into different tabs. So in this case, there's different math functions, sets of numbers, sets of data, right? If you want random data, duplicate, there's a Fibonacci sequence number generator. Some of the things that we've explored in this class, you can see here, right? There's a random list of pseudo random numbers here. There's a whole tab for vector, so all the planes, right? If you have a series of planes that you want to create, different types of grids, from square, rectangular, radial, hexagonal, triangular, just to drop these in. A lot of these components will have default settings. So when you look in Rhino, it'll actually have, and I click on this to show that it's active, it turns green when I do that. So this is the triangular grid that this is automatically generating. So all I had to do is click on triangular, drop it in, and that's under vector. Yes. So in order to change the units in Grasshopper, you're going to change the units in Rhino. So in Rhino, if I just type units, I'm already working in feet, so that's good. Let's say I wanted to go into inches. I would change this to inches, and maybe I set this to feet and inches. Scale, yes. And so now every, if I tell this triangular grid that the size of my edges, I want 3, right? Now it's going to assume 3 inches, right? So 3 inches instead of feet. If I were to change my Rhino units to feet, that would be 3 feet. So it's just, Grasshopper is just generating the numbers and then it's converting them to whatever units you have in Rhino. Yeah. Okay, so that's a triangular grid. And then just if you ever wonder, what a component does, just put your mouse over the center of it. It'll tell you what the component is doing, what it's functioning as. And then if you mouse over any of these inputs on the left, right, the left are inputs, it'll ask you, okay, it's looking for a base plane, or it's looking for the size of my triangle edges. So always mouse over these to see what it's looking for. So that'll help you, because you can't just plug anything into this, right? It's looking for a base plane. So if I bring in a mesh, it'll get confused. It won't like that, right? But if I give it an XZ plane, right, now it's using this XZ plane as the plane for my triangular grid. And I can hide this component. Again, I can select it, I can right click and say preview off if I want to hide any one component. And now you'll see that it's creating a triangular grid on the XZ plane. And you'll notice I just double clicked on the canvas to pull up that component. So if you know the name of a component, you can double click, for example, and type line. Just make sure you're grabbing the right one because there's many options. There's the param line, which you can just, assign from Rhino, or there's the line that you have to derive in Grasshopper that comes from 2 points. So when you double click on the canvas and you start typing something, let's say sphere, just make sure you're clicking on the correct one, okay? Because there's many ways of making a sphere, for example, and there's many other components here too. Okay, so that's one way to summon a component. These are called components, right? They look like batteries. And again, this is originally created from the Lego Mindstorms interface that allows young kids to build Lego and then write their own programs and then send those programs to the little robot controller, and they can make little motors and things like that move and add sensors to it. So that whole interface was designed to let kids who have no experience in scripting help them learn how to code by just connecting a series of blocks together, and it's going to read it from left to right. Okay, so that's the interface that Grasshopper has adopted, and it's really effective because I don't know how to code, and I think it's a much more cumbersome way to design something. As designers, we don't often have the time to learn how to code, and this interface can be really helpful. All right, so again, just mousing over this, it's asking for the number of grid cells in base plane X direction. So how many grid cells am I going to have in this direction, and how many grid cells am I going to have in the Y direction? So this is also looking for a number. So I can double click on the canvas and just start typing a number. So let's say 4. If I plug that in, this is a number slider, so I can play with this and you'll see the number of grid cells is changing based on this slider. Okay. And so that's one way to do it. I can also go to params, input, and find my number slider this way. Click on it, but you'll notice it defaults to 0 to 1. How do I change the range of that number slider? What's that? I could right click. No, I have to double click it. Yeah. Yeah, so when you double click it. Oh yeah, you can do that too. Yep. So you can right click and hit edit, and you can set the minimum and maximum of that numeric domain here. Okay, so I can set my maximum to 20, hit OK, and I can now play with that. If I want these to be whole integers, I can right click, edit, and set this to integers n and hit OK, and now it's not going to have any decimal points. So I can plug that in here. Okay, so you'll see that now I have this tower or some vertical pattern that I can play with here. Okay, all based on number sliders. So number sliders are useful if you want to test different sizes or test different numbers graphically and kind of see that live. Okay, so hopefully you're all following along. And again, I got this triangular grid by going to Vector, Grid, and Triangular Grid. Click on that. And again, if I just know the name of that component, I can double click on the canvas and type triangular grid, and I can drop it in that way. All right, so I'm using number sliders to input into this, but there's other ways that I can assign a number. I can also zoom in on this component, just right click and set an integer manually. I can set that to 20, and you'll see that update here. Okay, so again, if I mouse over it, now you'll see that number 20 in the bottom of that text box. So when you mouse over this, it'll tell you the number that it's receiving there. Again, but when I bring in this number slider, it's going to override that number that I've input. Okay, what's the other way to give this a number? That's what we did last class. We could just go to params, find the number here, drop that in, drag it in, and I have to set this as set a number for this component. So I can right click it, set number, and say 15. Okay, so now it's creating 15 cells in that vertical direction, creating 3 cells in this direction. I can increase that. Actually, that's the size. I can increase the number of cells in that direction. Yeah. The number sliders, I could just double click and start typing a number. So 45, boom. Yeah, for this triangular grid, I went to Vector, Grid, Triangular Grid. And I could do this with a hexagonal grid, right? Same thing. I'm going to plug in, let's say I want the YZ plane. So I can double click and type YZ. That's going to give me a plane in the YZ direction. I'm going to unpreview all this, so I'll preview off. Okay, so I have a hex grid and I want it to use this plane. So if I mouse over this, it's looking for a base plane. So I can plug that in. And now my hex grid just went vertical. And again, I can change the scale. So I can use all the same things I did here. So I can pull in a number slider. I'll say 12 as my default, and I can bring that down. Number of cells, let's say 24. Control C, Control V to copy and paste. I can plug that in. And you'll see now I have a hex grid of cells that I can play with the number slider. Okay, and this is just an example of the way this works. So I'm telling it use the YZ plane here, but if I just unplug this, it's going to default to the XY plane. So if I mouse over the P, you'll see that it says world XY. That means the kind of world coordinates use the XY plane, and you'll see it now on the XY plane. Okay, so this is a really powerful tool, just understanding how you can play with parameters and then watch the geometry adjust in real time. It's a new way of designing relatively, and it's kind of making the life of architects and designers a lot easier, but it's also opening up ideas that, opening us up to ideas that and iterations that we may have not come up with otherwise. Okay, so that's just kind of the basics of the interface. And then if I want my computer to stop calculating this, let's say this calculation is taking up a lot of time and it's slowing my computer down, I can select it and middle mouse click and hit disable, and now it's disabled. So it's not going to calculate that anymore. Whereas just because I've hidden or turned off the preview on this one, Grasshopper is still calculating it. So if I wanted to reveal just this, I can right click, preview on, and now I can see it again. Okay, and then who remembers how to get the geometry into Rhino? You bake it. Yeah, so I select this and I middle mouse click and hit bake. And now if I close Grasshopper, you'll see that this geometry is now baked into Rhino, and I can manipulate this. I could hit extrude. All right, so I can now manipulate this geometry. I can move these. So now this becomes editable in Rhino. And again, whenever you're working, make sure to save your Rhino file. And make sure to save your Grasshopper file too. So if I type Grasshopper, that screen pops back up. I'm going to hit save here. And I like to have corresponding names, so you always remember which Grasshopper file is associated with that Rhino file that you're working on. So yeah, so that's the basics of the interface, how to bring in a component into the canvas. I'm going to delete these. That's not part of this tutorial. The tutorial here that we're going to look at is how to create points, generate some curves from those points, how to create a lofted surface from those curves, and then how to make something three-dimensional, how to make a 3D geometry. Again, so if you're not in Rhino, go ahead and open up Rhino and follow along if you can. Okay, everyone have Rhino open? All right, so the first thing we're going to do is create a series of points. And this will turn into classwork, so it'll be very helpful to follow along. I'm going to create these points in Rhino, and then I'm going to assign them into my Grasshopper file here. Okay, so I'll create a series of points in Rhino, and I'll let you go ahead and do that. So I just type point, and I'm just going to click. I'm going to select, I'm just going to create 4 points here. And I'm going to create a series of 4 points out here too, both kind of in a line almost, or in a curve. All right, so create 8 points total. Okay, how would I get these points into Grasshopper? Yeah. Yeah, so I have to go to params, find the point parameter, and params are all the things that we're bringing in from Rhino, right? It's kind of the pipeline, it's the way in to Grasshopper. So anytime you want to bring in a curve or bring in a B-rep, like a geometry, or you want to bring in a surface, bring in the parameter and drop that into your canvas. Okay, so I have a point that I just brought in. What I want to do is set multiple points and assign all of them to this. So I'm going to set these 4 points to this component. So the way I do that is I select it, I right-click it, set multiple points, then just grab all of these points. Now, if I just select and drag, it's going to select these points based on the order I created them. But if I want to be very specific in which, in the order that these go in, I'm going to just select one by one each point and then hit enter. Okay, so now you'll see that this is gray. It was orange before. If I were to create another one, I could double click and type point, make sure I grab the parameter. Notice how it's orange because there's no data in this. But now that this has data, it has these points, it's going to be light gray. And then when I select it, it turns green. Okay, so I'm going to do the same thing with these. I want these 4 points to be called by this point component. So I select it, I right-click it, set multiple points, and then just go one by one and make sure the order that I select these is correct and hit enter. Okay, so now I have a series of points here and a series of points here. These are my first set of points, these are my second set of points. Now what I want to do is create a polyline that connects all of my first set of points. So to do that, I would go to curve, make this a little bigger. You'll see that there are a series of different types of curves within that. So here there's analysis, division, primitive, spline, and under spline you'll see polyline. So what polyline is going to do, and if I mouse over it, it'll give me a little definition or a little explanation of what it does. So it says create a polyline connecting a number of points. So that's what we want. We want to create a polyline, and then from that polyline we want to smooth, we want to fillet the edges of that polyline. So we'll first create the polyline. And what's the first thing we do whenever we pull in a new component? How do we know what it's looking for? Yeah. Hover over it. So I'm going to hover over the definition, see what, hover over the middle of it. It'll say, okay, it's creating a polyline from a number of points. Then I mouse over what it's looking for. So it's looking for polyline vertex points. How convenient. I just click and drag. Now each of these points is a point in my polyline, and you'll see that Grasshopper is now generating that here, and I can move these points in Rhino, and it's going to move that polyline in Grasshopper, right? And when I select it, so it's red by default, and then when I select the component, it turns green, telling me that it's selected or it's highlighted. Okay, so now I have a series of points connecting to become a polyline. Yeah. So polyline came from curve tab, spline, polyline. And if I want to do the same thing for these points, I can also just copy and paste this polyline. So I can select it, Control C, Control V. You'll notice that it's still connected. If you ever want to disconnect a connection, I can hold Control, select, and notice how it turns red. You see that little red arrow? Now it disconnects that. And then I can just select, click and drag, and it brings this in. And so now this polyline is being derived from these points. And I can move these around, and it updates my polyline. All right, and like I did before, I could bake this polyline if I wanted to. Select it, middle mouse click, bake. I can close Grasshopper, and you'll see that now this is a Rhino geometry that I can edit and manipulate. Okay, so that's the workflow here that we're going to be working with. And every time I want to bring Grasshopper back, I just type Grasshopper and it comes back. All right, so right now I have 2 polylines, all being generated from a series of points. And what I want to do is I want to create soft edges. I don't want sharp edges of this because I want to generate a surface between these that is a smooth surface. So I want to fillet this before I generate a surface from these 2 curves. Yeah, you're right. Yeah, if you want to change the preview color, is that what you want to do? So you can change the preview color over here by document preview settings. So by default, it's set to red, and when it's selected, it turns green. So let's say by default, I want it a little bit more intense red. Right, I can do that. And when it's selected, maybe I want this to be blue. Right, I can hit OK. And so now it's a little bit more intense of a red, and when I select it, it turns blue instead. Okay, so that's all right here. All right, so I have 2 polylines. How do I smooth the sharp corners of a polyline or of a surface? How would I do that in Rhino? Fillet, yeah. And so just like you would in Rhino, we could do the same thing in Grasshopper. So I can double click and type fillet, bring that up. And that's also found under curve, utility, and if you click on this, you'll see that fillet is right here. Okay, so there's also other ways to fillet. I could fillet based on a curve parameter. I can fillet based on a distance. Okay, so there's many ways to do the same thing in Rhino and in Grasshopper. Okay, so again, first step is mouse over it. Tells me what this is doing. Then I mouse over the inputs. It's looking for a curve to fillet. Okay, so I can plug in this polyline that I have. That'll work nicely as the curve to fillet. And how come it's still orange? Orange means that it's not collecting enough data. What is it looking for? Yeah, so I need a radius. So if I mouse over this, it'll say, oh, I need a radius. So I could give it a radius. How would I do that? How do I give it a number? Double click. I can give it a number, right? If I just want a floating number, I can give it, let's say, right click, set number to 2.5. And if I zoom in, now it's getting it a 2.5 inch or foot, whatever my Rhino units are. It's filleting that radius based on that. Let's say I want to give it a number slider. I can double click and just start typing a number. I'll say 13.6, right? Any number. And now you'll see that it's filleting with a larger radius, and I can play with that radius with my number slider. See how that fillet is changing, and it's a little distracting to see this original polyline. So how would I hide this component? I want to hide both of these. Select it, right click, and say preview off. Okay, so now I'm only seeing this filleted curve. So I can see how changing this fillet number is going to affect my geometry. And so I can move this, right? I'm still moving my Rhino points and still seeing how Grasshopper is taking those points, turning them into a polyline, and then filleting that curve. And when I'm happy with this, I can select it, middle mouse click, and bake it, and then now it's in Rhino. Okay, so now I have a really nice controlled curve that I created in Grasshopper and then brought into Rhino. So if if my workflow called for a series of these curves, and I was working in Rhino. You can see how I can manipulate these curves. I can loft them together if I type loft, right? So I could work in Rhino based on my Grasshopper geometry this way, right? But let's say I want to do this loft in Grasshopper, and I want to be able to play with this edge, do this and see how it updates in real time. Okay, so I'll show you how to do that. Okay, so I have my polyline. It's being filleted based on this radius. I want to do the same thing for this other curve that I did here. So I can just select these, Control C, Control V, and then to replace this cable, I can just drag this one in and it replaces it. Now, if I wanted both, right, Control Z, if I wanted both, I can hold Shift and drag, and now it's streaming both polylines into this fillet, right? So there's different ways of doing it. Then if I just select without holding Shift, it'll only select these. Okay, and then same thing, I want to hide this, so I select, right-click, preview off, and so now I have two polylines that are turning into filleted curves. And let's say I've played with this a little bit. I realize, you know what, I want these to both be the same radius. So what I could do is I can just have this same slider plug into both components to fillet so that now both fillets are getting the same radius. Okay, so I can play with that, and now the same slider is now affecting both curves that it's making simultaneously. All right, and I can, again, make this three-dimensional. I can play with the heights of these points. I can play with where they are in Rhino space. And it's going to affect my Grasshopper curves. All right, so let's say this is the geometry that I'm happy with, and I want to create a surface between these two curves. The component that I would use, so now we're going to go into the Surface tab. So again, I'm going kind of in order of the way Rhino and Grasshopper both work. Points, curves, surfaces, solid geometry, right? That's generally the workflow that we use. So I started with points. I created a polyline from those points. I filleted that polyline. I have two curves, and I want to generate a surface now between those two. Any ideas on what kind of component I would use there? We use the loft, right? So we could use loft. By default, loft is going to allow multiple curves to go into the same input here. So if I mouse over this, it's asking for section curves. It's also asking for a series of options, but these are already by default being inputted, so I'm going to leave those as is. But you'll notice now that in Grasshopper, I have a surface here that is editable in Rhino. So I can manipulate these points. The points manipulate the polyline gets filleted, and those filleted curves are now being lofted together in Grasshopper. So if you have a surface, let's say you're generating a roof surface or your terrain for your project, this could be an effective, very effective technique for your project. Okay, so again, let's say I look at this and I say, well, I want this fillet to be a little larger. I want that radius to be larger. I can now change this, and now it's changing not only my curves, but the entire surface is being adjusted here too. Okay, so let's say this is a roof structure for a project that I'm working on. And let's say I want to give this thickness. I don't want this to be just an infinitely thin plane. I want this to be a structural shell. How would I generate a 3D geometry base or a thickened shell based on this surface. Yeah. Other input. So we've been in the surface tab. Now we're going to take things a step further. There's also mesh, which is another type of geometry. It's a triangle-based three-dimensional geometry. Similar to surfaces, but surfaces have a U and a V direction to them. If I were to just kind of simply illustrate that, if this is a surface, every surface has divisions in one direction, which are called the U direction, and then it also has divisions in the other direction, which is the V direction. Okay, so that's a surface. A mesh, however, is based on vertices, which imagine are points, and it has mesh edges, which connect those points. So if you've ever seen a mesh, you'll see that it's broken down into a series of triangles, right? So it does this. So it's a different way of calculating surface topology, right? So this is point-based. It's based on, and again, this is a mesh. So this is a mesh. This is a surface. Okay. So different ways of generating a surface or any kind of surface typology. Okay. Surfaces have a U and a V direction, which can be valuable in Grasshopper because we can, when you're later on when you learn how to subdivide a surface, you can subdivide it based on the U and the V, and you can do a lot of things to that surface. You can add a grid pattern to it. You can add geometry that you can have scale based on attractor points, and you can manipulate that surface based on these U and V values, and you can get more control over the surface that way. With a mesh, it's a little harder to control the directionality of it, but that's just later on. Okay, so I have a loft, which is actually a poly surface, because you can see where it's filleting, it's actually subdividing. It's actually subdividing that surface. So if I were to bake this, so now this is in Rhino, and I were to hit explode, you'll see that there's a number of different surfaces that came out of this. So this is called a poly surface, where it's multiple geometries in one. I'll hit Control Z a few times, open up Grasshopper again by typing it and hitting enter. I have this lofted surface. I want to make it three-dimensional. So there's a couple different ways to do that. Under utility, so I went to surface. Under utility, you'll see that there is an offset surface command here. So if I mouse over it, it says offset a surface by a fixed amount. So this is one way I can do this. So I can take the surface and I mouse over what it's looking for. It's looking for a base surface. I could plug my lofted surface into that. And it's turning red because if I mouse over this, data conversion failed from a BREP to a surface. So what's happening here is this loft is actually a poly surface. It's not an individual surface. This offset is looking for an individual surface that it can just easily offset, can make three-dimensional. But what it's getting is many surfaces, so it's getting confused. It's saying, how do I offset many surfaces in the same direction? It's not computing, so it's turning red here. All right, so one way that I can get around this is by not having this loft create multiple surfaces to begin with, right? Let's say I want this to just be one curve and not a series of curves. So if I were to bake this fillet, you'll notice if I select it and hit explode, it's actually curve is being broken up into 5 segments. 1, 2, 3, 4, 5. So what I want to do is tell Grasshopper, instead of making this curve a series of arcs, I want this to be one smooth curve. And if it is one curve, when I loft it, it'll make one smooth surface. So the way I do that is I select this fillet. I can add rebuild curve. So this is another curve component. So under curve, maximize that. Under utilities, you'll see rebuild curve here. Or again, curve tab, utility, rebuild curve. So what this will do is, instead of having 5 separate segments, it's going to rebuild it into one curve. So I can select this fillet curve, bring that into my curve because it's looking for a curve. It's asking for a degree, so that's basically how precise you want this thing to be. The number of control points, I'm going to turn this up to 20 with a number slider. And so now that original filleted curve is being rebuilt. And if I want a low number, it's going to have very little accuracy. If I increase this, it'll have a lot more accuracy when it rebuilds it. But it's rebuilding it into one continuous curve. Okay, so now if I select this, I want to do the same thing for this fillet, so I'm going to select both. Or I could actually just select this one, Control C, Control V. Now I'm going to pull this fillet in, and now this curve is also being rebuilt in this one. Okay, so now you're seeing what I'm setting up. I have 2 rebuilt curves that I'm now going to loft. So instead of the loft connecting these two, I want that loft to connect this and this. And now it's creating a loft based on my rebuilt curves, which it sees it as one curve and not 5 because I rebuilt it. And now it's a loft, and now all of a sudden this offset is working. It's no longer red, right? And so the offset is looking for a surface. It's looking for an offset distance. So my offset distance, I'm going to set to 5.65. And now, because it has, by adding that 6.5, it gives me 2 decimal places. I can select that, plug it into my distance. And so you'll see that it is now creating an offset surface, right? This is my offset. I can toggle this and see how that changes here. So now it's offsetting these. Let's say I wanted to connect the 2 edges. Let's say I wanted a solid offset. So you'll see that just by default, Grasshopper doesn't have a solid offset. So the way that we're going to do this is we're going to take this edge and we're going to take this edge and we're going to loft the 2 together to create a solid shell. Okay, so I want the edge of this and I want the edge of this, and I'm going to loft those 2 together so I have a solid shell, right? Because I don't want this hollow shell here. If I'm making a roof structure, I want it to be solid. Okay. So I'm going to grab the edge of this and the edge of this and connect the 2. So one thing I'm going to do here, I want to grab the curve from that surface. So there's a way to grab, I think it's under, yeah. So if I grab brep edges, so I can grab the edges. So this will extract the edges of a brep. So the edges of a poly surface or of a geometry, it'll take those edges. So I want the edges of this first surface, and you'll see that it's outputting naked edges, which are the edges along the perimeter. It'll output any interior edges that it has. I don't have any, so I just have a series of edges here. And when I mouse over it, it'll tell me what is being output in that part of the component. Okay, so I've got those edges of my first one. I'm going to do the same thing for my offset surface. I'm going to select the edges, Control C, Control V, plug that in. Now in blue, you'll see that I have edges of my second surface. So how do I create a surface between the edges of my first and the edges of my second? What would I do in Rhino normally? Normally I would loft, the same way we did this earlier. But there's also another one called ruled surface that is unique to Grasshopper. So with ruled surface, it's similar to loft, but it just allows me to have two separate curves that I input, and it'll generate a surface between the two. Okay, so you'll notice that now I have a freeform surface, and when I select it, it turns blue. So I have now a thickened geometry here. And again, all of this is based on my offset distance, so I can play with that. So if you want to see this reacting in real time, I can change the thickness of my roof. So let's say the structural engineer gets back to me and says, well, the structure of this roof has to be thickened. Now I can change, okay, this has to get thicker. So it'll be a thicker shell or a thicker roof structure. And let's say I want to bake this, and instead of just baking each surface individually, I want to bake this in a way that these are all joined together. So I can double click on the canvas and type join, and you'll see brep join or brep join. I'm going to go in, and again, join, mouse over it, join a number of breps together. So I'm going to join this edge, or this surface, and this surface. I'm going to join them all together into this one component. So the first thing I'm going to add is this ruled surface. Next thing I'm going to add is my offset surface. So I hold shift because I want multiple things to go into this. And then I'm going to hold shift for my lofted surface. So all three of those surfaces are now contained in my join, and it's joining them all together. So I'm going to hide all of these, preview off. So the only thing I see now is my joined surface. And if I bake this, notice these aren't actually joined the way I wanted. So what I have to do, and this is more advanced, but I'm going to right click and say flatten. And so what that does is it just kind of flattens the data tree. So it's more advanced, but this is flattening the data so that it sees it all kind of together. So I can middle mouse click and hit bake. And now when I select this, this is one geometry. And so this is a powerful workflow. So let's say I've done that here. I'm happy with that, but let's say I want to modify this design a little bit. So I could go in and I can change the parameters that I've set here. I can change these parameters, but also I can move these original points that I made in Rhino, and you'll see the geometry morphing with it. Okay, so this could be a really powerful tool when you're looking at different design options, or you have a client that has changed their mind on something, or if a consultant has another piece of input they need to give you. And so I can bake this one. So you'll see that I can quickly come up with a series of iterations of an idea really easily, right? And I can move these points to adjust all of that. All right, so I'm changing the geometry. I can select this, middle mouse click, hit bake, and I've just now created 3 shell structures that all have different topologies. Right? All relatively quickly, all, if you were to manually model this in Rhino, it would be a lot more time consuming. You probably wouldn't have the energy to come up with all 3, but the fact that we have this workflow means that I can play with these really easily and get this to update and change really quickly. Yeah.
Do you have any join components that you in one offset? Right?
I connected all of them. So I'm joining. So yeah, so what I'm doing with the edge component is I'm saying, I'm going to turn these on.
Oh, I see what's going on.
Yeah, so I'm creating a ruled surface between these 2 curves. Yeah.
Then you have to make it.
So yeah, so then my ruled surface, which is this, is being joined with the top surface of that shell, right, which is my offset, and it's being joined with my bottom surface of that shell, which is my loft. So this, and this are all being joined together to form one solid shell. Yep. All right, so I'll make this video available to you, and I'll also post this Grasshopper script, which again, it's derived from 2 sets of points. And I'll let you play with this and modify it as needed. All right, so notice how I save my Grasshopper file, I save my Rhino file, and if I close this and I open it back up later, so let's say I close this. I'm going to select this, hit close, close out of this, close out of that. And let's say I open up Grasshopper again. I can find that file that I was working on and open it up, and now it's going to generate this. It'll go through the calculations to generate that surface again. And as long as these original points are still here, Grasshopper is going to find them and start running its script because my initial inputs are still there. All right, now if I were to open up a new file, notice how everything just turned orange, this turned red. It's having all these problems because it can't find the original input points that I created because this is now a new file. So what I would have to do is either create new points in this file, and reassign them, set multiple points, right click, set multiple points, and now I have a new geometry based on these points that I created. Okay, and then this whole thing is now functioning. The other way to do this, and this is more advanced, would be, let's say I want to have these points in Grasshopper so that I don't have to do that whole process over again. I can right click this and say internalize data. I can right click this, say internalize data. Now those points are now baked into this component so that even if I create a new file, so don't save, it's still going to run based on those points. And if I turn this on, I'll see a preview of those points. So it's basically a way of saying, instead of relying on the Rhino points, now I have them kind of baked into my Grasshopper script. And you'll see these arrows I can now play with this gumball, or this triad I can now manipulate by simply just selecting points. I can now manipulate that. Okay, so that's because I've internalized that data, which is good if you're ever file sharing or you want to send your Grasshopper file to someone and you don't want to send them the initial Rhino input. That's one way to do it, so that that data follows the Grasshopper file. Yeah. Could I add a point? Yeah, so if I have these points and I want to create a new point to this, I can say right click and say set multiple points. Well, this might get tough. So I can say add item. So I'm going to add this item that I created here. Let's see. This gets a little more complicated because I'm trying to add a physical point when I've internalized all of these. I think what I would do here is I would bake these. So middle mouse bake, and then I would select all of these and assign them all to set multiple points. Actually, I think I have to hit clear data first. Clear values. Yeah, it's a little more complicated. So I'm going to right click, set multiple points, add all of these, hit enter. And so now I was able to do it, but I first had to bake this and then add a new one and then set multiple points. So it gets a little more confusing. As far as I know, there may be a better way to do that, but that's how to do that. All right, so I'm going to save this. I'll make it available on Canvas for you, and you'll be able to follow along because I've recorded this.